All right, good morning. Welcome back to Calculus 2. We are going to be looking at this problem here, the integral of 2x squared minus 1 over 4x minus 1 times x squared plus 1 dx. We're going to try to integrate this thing. First thing I'm looking at with this problem is that there is no obvious u substitution. The degree of the top is going to be 2. The degree of the bottom is going to be 3. It's a proper fraction, so we don't have to do any kind of polynomial division. I'm looking at this. I'm like, why don't we just set this up as partial fractions and see how it goes? So we're going to break this apart. We're going to say we have an a over 4x minus 1 because this is a linear term. And then we have a irreducible quadratic. So we're going to need a bx plus c over x squared plus 1. Okay. Now, what we're going to do is we're going to say we need we need a over 4x minus 1 here. Okay, so we have a over 4x minus 1 plus bx plus c over x squared plus 1 equals 2x squared minus 1 over 4x minus 1 x squared plus 1. What we're going to do, we have a rational equation here, and the first step in having a rational equation is to make it not a rational equation. So what we're going to do is we're going to clear the fractions, because who likes the fractions? And the answer is nobody. Nobody likes the fractions. So we're going to go ahead and multiply everything through by the denominator to clear the fraction. So here we have the 4x minus 1's cancel, so we have x squared plus 1 plus bx plus c, put that in parentheses. The x squared plus 1s are going to cancel, so that still leaves a 4x minus 1 left here. On the other side, the whole denominators cancel. That was the point. Okay, so I've got this x squared plus 1 plus bx plus c times 4x minus 1 equals 2x squared minus 1. Let's factor this stuff out. So we've got an ax squared plus a plus, we're just foiling this out. Okay, we've got a 4bx squared. Okay, let's see. We have a minus bx plus 4cx minus c is equal to 2x squared minus 1. That looks like an awful lot of numbers or an awful lot of parameters to figure out. So what we're going to do is we're going to do something called equate the coefficient. I'm going to claim that all the stuff that adds up to x squared on the left side has to equal to the stuff that adds up to x squared on the right side. The same thing for the x's. So the stuff on the side on the left with the x's in it has to equal to the stuff on the right with the x's. And the same thing with the constants. So we're going to write down a little chart here. We're going to say my x squareds. We have a plus 4b is equal to 2. Okay. For my constant term, my linear term, my x, we have 4b. Oh, no, we don't. We have negative b plus 4c is equal to, well, I'm looking at the right-hand side. I don't see any x's. Does that mean I just ignore this? Like, no, that means there's 0 of them. Okay. And then for my constant term, we have a minus c is equal to negative 1. And that's a little equation that we have to solve here. Okay. It's not too bad. So it's 3 equations, 3 unknowns. So that is a little bit long. So what I'm going to do is I'm going to take my last equation. I'm going to multiply it by negative 1 because my goal is to get rid of my a's. So I've got a plus 4b is equal to 2. And what I'm going to do is I'm going to multiply this whole equation on this bottom by negative 1. So I have negative a plus c is equal to positive 1. Okay. And then what we're going to do is we're just going to add these two together. Okay. The a's cancel. That was the point. I've got 4b plus c is equal to 3. Okay. Now I'm expecting what was going on up here, and I'm saying, okay, do I have anything else with b's and c's in it? I sure do. I have negative b plus 4c is equal to 0. So we have the two equations. Let's go ahead and get rid of that one mark there. Okay. So we have the two equations. We have negative b plus 4c is equal to 0. Negative b plus 4c is equal to 0. And I have 4b plus c is equal to 3. Well, what I'm going to do is I'm going to multiply this top equation by 4. So I have negative 4b plus 16c is equal to 4 times 0, 0. 4b plus c is equal to 3. And I'm just going to add these two together. The b's cancel. That was the point. So we've got 17c is equal to 3, or c is equal to 3/17. Okay, even though I did get this problem out of a textbook, if you're not really careful about picking your numbers, it's real easy to get horrible numbers like this. Okay, but that's what we're left with. Okay, we've got C is equal to 3/17. Okay, now what I'm going to do is I'm going to go back up into my other pieces here. And I'm going to say, well, we've got this. Let's see what else we could do with this thing. So we've got my top one. So those my so we've got I'm just looking for pieces to be able to figure out, like I need an A. So how about we do this third column? So we're going to say A minus C is equal to -1. Okay, that was my original equation. So we have, dang it. So we have A minus 3/17 is equal to -1. So we have A is equal to -17/17. That's a fancy way to write 1, plus 3/17. A is equal to -14/17. Okay, and that's another little thing that we want to keep. Okay, that's a little piece that we want to keep around here. Okay, and then we need to figure out our B's. Okay, so what do I have left for B? I've got, let's see, -B plus 4C is equal to 0. We can do, oh, we have A plus 4B is equal to 2. Let's do that. So we have A plus 4B is equal to 2. Okay. Okay, what is my A? So we have -14/17. Let's see, plus 4B is equal to 2. So let's go ahead and sort that out what B is going to be. So I've got 4B is equal to 2 plus 14/17. Well, a fancy way to write 2 is going to be 34/17. Okay, that's a semicolon, plus 14/17. I just replaced the 2 with another thing that looks like 2. This is equal to 4B. Okay, add these up. So we have 4B is equal to 34 plus 14. That's going to give me 48/17. Divide both sides by 4, and we have B is equal to 12/17. Okay, that's our third one that we actually wanted to keep. So that's great. Okay, let's go back to our actual integral. So we have A over 4x minus 3. So we have to go back up with what A is. So remember what A is. A is -14/17. Okay, so we're going to say this is equal to -14/17 times 1 over 4x minus 1. We're going to try to integrate this. Okay, plus B and C. B and C are contains, or B and C are combined. So I'm going to go ahead and pull out a 1/17 and say we've got 12x. What was C? C was plus 3. Okay, plus 3, and this is all over x squared plus 1. Okay, we have to integrate this piece as well. Okay, I'm going to break this up into two different pieces here because this 12x plus 3, they are both divisible by 3. That's nice. But rather than factor that out, I'm not going to get anything with this because my x squared plus 1 is not going to be friendly to figuring this out. So what we're going to say is we have -14/17 integral 1 over 4x minus 1 plus 1. Well, actually, how about 12/17? Because I'm pulling this apart. And I've got x over x squared plus 1. And we've got to integrate this, plus 3/17 times 1 over x squared plus 1, and we've got to integrate that. Okay, so I just broke that fraction up into two pieces to make it a little bit easier. Okay, these all have dx's attached to them. Okay, if you have to do a u substitution at this point, please do. Okay, I think at this point you probably practiced enough where you can kind of anticipate this to say u is going to be 4x minus 1, du is going to be 4. So we're going to multiply and divide by 4. So that's going to give me, we're going to get 4 down here. So the 2's are going to cancel. So I'm going to end up with -17 or -7/34. That's 2 times 17 times the natural log of 4x minus 1. Put that in absolute values because that's a thing you have to deal with. Okay. And let's see here. What are we doing next? We're looking at this piece in here. So we're going to say let u is equal to x squared plus 1. Du is going to be 2x. So we've got to multiply and divide by 2. So that's going to be plus 6/17 natural log of, you don't need absolute values on here because x squared plus 1 is never negative. So we're going to end up with this. Okay, and then we're going to have plus 3/17 inverse tangent of x, right? Because that's inverse tangent is 1/x² + 1. Okay, it's a really important integral to remember. Okay, try to remember. If it's really easy like this, you don't have to do a triangle. You can just remember what it is. If it's complicated, it's got extra terms in here. I didn't memorize it that way, so I've got to write the triangle. And then there's one thing we have to remember, plus c, of course. Okay, so that is my answer to this horrible integral, and that's what we're going to go with. Okay, thank you very much for watching the video, and I'll see you in the next one. Okay, take care.